Hello and welcome to this Camtasia screencast recording on the use of your calculator. In this session, what I plan to do is give you a little help getting to know your calculator. We'll then have a look at some sample calculations such as calculating with square roots. Then we'll have a look at calculating with powers and then talk a little bit about working with scientific notation. So in S141, the two most commonly used calculators are the two shown on the screen here. In this presentation, what I'm going to show you is how to actually use a Casio FX85 GT Plus and equivalent calculators. So on the right hand side of this screen, I'm actually running a calculator emulator for the Casio FX82ES, which is broadly similar to the FX85 GT Plus, which is the one that's shown in the picture on the slide. So to start off with, I'd like to have a look at some basic operations on the calculator, and I'm just going to run through some sample calculations, starting with the first one that's shown here, which is A, which is 25 times 2 plus 16. So just putting those values into the calculator. So 25 times 2 is 50, plus 16 is 66, and that should be the answer that's shown on the calculator, and you can see the answer as shown here. In B, this is just getting you used to actually putting negative numbers into the calculator. If we actually look on the calculator, you've got the negative symbol here, which we can actually use to put into a negative number. In this case, we don't really need to put in the brackets, so what I'm going to actually do is just put in the 834, then plus minus 425, and then minus negative number 129, and press equals, and we get the answer 538 as shown on the screen. And then in C, we've got 25 plus 2 times 16. So in the order of operations, it's 2 times 16 is 32, plus 25 is 57. So writing it in the calculator would be 25 plus 2 times 16, and the calculator automatically knows the order of operations it should be following, and it gives the answer of 57. And then in D, there are a couple of ways of actually putting in calculations like this one. One way is actually to press on the fraction symbol here, and then what we could do is we could do 25 plus 2 plus 16 in the numerator. Press the down arrow to go to the denominator, and do divided by 7, and press equals, and it's given me the answer as a fraction, 43 over 7, and we can convert that to a decimal by pressing the SD key, and that gives me the answer of 6.1 to 2 significant figures. Second way of doing the final one, what I could do is put the values in the numerator into brackets, which is 25 plus 2 plus 16, close the bracket, and then press divided by 7, and the same answer gets recorded as before. So in the example D, what the calculator did was evaluated all the numbers in the numerator first, shown above the solid line, and then did the division by 7. So your calculator instantly knows the rules for the order of operations, which are known as bedmass. And here bedmass gives us a way of actually remembering what the order of operations are on the calculator. So B stands for brackets, E for exponents or powers, D for division, M for multiplication, A for addition, and S for subtraction. So there's a hierarchy of operations, so anything in the brackets is done first, that's then followed by exponents, then followed by division and multiplication, and then followed by finally addition and subtraction. So if you enter in negative numbers on a calculator, if you're actually just doing 9 minus 3, then you just use the minus sign, which we actually see there. To indicate a negative number, we've got this key here, and we can actually say put in minus 129. If I press equals, it just tells me the answer is minus 129. So on the case of the Casio calculators, you can actually use either key for entering negative numbers. It works both ways, so there's no real need all of the time to use the negative key. If you are just doing put in a negative number, it is good practice just to select the negative symbol from here. So on the Casio calculator has a square root button. The square root button is here. If we press on it, we see the square root symbol is opened up. If I press 349 and then equals, it tells me the answer is square root of 349. Press the SD button, and that gives me an answer of 18.7 to 1 decimal place. And you can see the answer I've got on my calculator screen is identical to the one given in the PowerPoint here. So this has returned the value of 18.68 and so on. But of course the square root of 349 can also have another value, and of course the other value is the negative equivalent of that, because if you actually square minus 18.68154, you'll actually get 349 as you do with squaring the positive value. But I'd now like to have a go at doing some calculations with square roots. If we actually look at this particular example here, we've got the square root of 472 minus 53. So on the calculator, just clear everything, open up square root, then put 472 minus 53. So what we can see is the square root symbol is acting like a bracket. So everything's done under the square root symbol first, which is 472 minus 53, and then we evaluate the square root of the answer, which gives us square root of 419, and then that gives the final answer at 20.47. So answer A is the closest answer to the one that's given on the calculator screen here. So in the case of the Casio calculator, what we can see is the square root symbol is automatically extended to enclose all of the values, and that's effectively acting like a bracket. So what we've got here is the 472 minus 53 is performed first, and then the square root is evaluated. So the next thing to have a quick look at is evaluating with powers. And on the Casio calculator, we've actually got a separate button for squares. So if we actually pull in 2 and then press the squared button, you can see with the percentage is 2 squared. If I press equals, it gives me the answer of 4. So what I'm going to do is just do the example that's shown on the screen. So I'm going to square 3.1, so put 3.1 in, press the x squared key, and press equals. And what we find is we get the answer of 9.61. It's possible to get other powers by pressing the x to the power of key. So if we want 2 to the power of 4, as shown in the slide, we just press the 2 and the x to the power of key, and then add a 4 and evaluate and get the answer 16. So it's possible to do some calculations of powers. So I've just got a couple of examples here. So if you actually look at 3.51 to the power of 1.2 times 1.7 on the calculator, it's possible to put that in exactly as shown on the screen. So we've got 3.51, then x to the power of 1.2. I've accidentally put 12 there, so put 1.2. Then I need to press the right arrow here to take me out of the exponential function, and then times 1.7. So just make sure that the time symbol is shown at the normal level and not as directly following on from the power. And then press equals to get the answer, and it gives me the answer of 7.67 to three significant figures. In the case of B, there are several ways of actually doing it. What we can do here, we can actually open up the fraction, and if I put in 3.42, and then that's going to be to the power of 3, so x to the power of 3, and then in the bottom, here I have to press the right key a couple of times to get to the bottom, and then 1.2 squared, so I can just press the squared key for that, and then press equals, and that gives me the answer of 27.8 to three significant figures. So these things are actually confirmed on the slide here. So these are actually the values you should get if you perform these calculations. So if you don't get the answers the same, make sure you have inputted the values correctly and exited the exponential function when actually putting 3.51 to the power of 1.2. So make sure you're not actually multiplying two things in the exponential function. So just take care when entering the values. Part B, the second way of actually entering that calculation as an alternative to the way I showed originally, is put in 3.42 in brackets, and we can have that to the power of 3. Press the right arrow to get us out of the exponential function, close the bracket, and then do divided by, and then we can open a bracket, 1.2 squared, and press the right bracket to get out of the exponential function, and press equals, and you can see entering the data like that we get the same answer. So now just have a quick look at scientific notation. So all scientific notation is where we have an initial number between 1 and 9 multiplied by a power of 10. And some examples of that could be 2.54 times 10 to the power of 3 and 4.63 times 10 to the power of minus 4. So on the calculator, if I actually input 2.54 times 10 to the power of 3, we get the answer 2540. So when entering powers of 10, I'll just put in this one here, 4.63, we're using this key here to put in the power of 10, and then our power is minus 4, so we're using the little minus sign there, and minus 4, and pressing equals, and that's given me the answer is 4.63 times 10 to the minus 4, and that's the value that's actually recorded on the calculator, so the calculator is automatically displaying that number in scientific notation. So your calculator would automatically switch to scientific notation for very large and very small numbers. So this example of scientific notation, what we can do is put in this particular calculation here, so 200,000 times 450,000, and press equals, and that gives me the answer of 9 times 10 to the power of 10. So the calculator doesn't have enough digits to display the original number, and as you can see, the calculator is given the answer in scientific notation. It is possible to program the calculator to give the answer in scientific notation to an appropriate number of significant figures if you want to do so, and I'll show you how to do that at the end. So scientific notation on the calculator, we've already mentioned that before. We've got times 10 to the power of button at the bottom. So if I actually put in 2.5 times 10 to the power of 3, press equals, I get the answer 2,500. So just run through some examples of evaluating these these calculations using scientific notation, so just putting the first one in. Got 6.12 times 10 to the power of 2, and then that's multiplied by 2.9 times 10 to the power of minus 7. Press equals, and that gives me the answer of 1.77 times 10 to the minus 4, giving the answer to 3 significant figures. The next one's a little bit trickier, because what we've got the square root of 2.3 times 10 to the minus 4, which we need to take first before multiplying it by the other values. So you've got to be careful about how to input the 1 and b. What we can do, just hit the wrong key there, is open up everything as a fraction, as we did before. Like I put in 4.3 times 10 to the power of 3. Press the arrow, went too far, until it's on the flashing next to the box on the bottom. Open the square root symbol. 2.3 times 10 to the power of 4. We now need to press the right key once, so that takes us out of the square root symbol, and I can now press times 5.1 times 10 to the power of 6. I then just press equals to get the answer to that, and that gives me 5.56 times 10 to the minus 6 as the answer. And then the final bottom one, what we've got again, I'll open up the fraction, and 10 to the 4 is the same as 1 times 10 to the power of 4, and then that's multiplied by 1.79. I've accidentally put in 179, so it should be 1.79 times 10 to the power of minus 6. Press the right arrow key until we come to the bottom, which we already have done. 3.18 times 10 to the power of minus 3 in the denominator, and press equals, and we get the answer of 5.63, just 3 significant figures. So these calculations with the answers are actually shown on the next slide, which is here. So you see the final one, the answer there is 5.63. So anytime you're carrying out calculations, I always ask you if the answer the calculator returns appears to be reasonable. So have an idea about the magnitude of the answers that you're expecting to get. So on the calculator, when you're actually performing calculations, you may need to actually put in brackets. So if you're actually entering everything on one line on the calculator, put all the values in the numerator and denominator of any fractions into brackets. But the great thing about the more modern Casio calculators is you've got natural displays, so it's possible to put everything in the same format as it's been printed. Do watch out for errors when you're actually performing calculations. I'd always make sure your calculator is actually in the correct mode when you're setting it up. So on the top you've got various modes. If we press shift and set up, you see we've got various options here, and some of those options are degrees, gradients and radians. So always make sure your calculator is set has to set to the appropriate setting here. 7 is for scientific notation. If I actually go into mode 7, what I'll do is actually press 7, and it just asks me to give the number of significant figures I want to give my answers to. If I press 3, it'll give me the answers to 3 significant figures. So now all answers are given in scientific notation and will be given to 3 significant figures. So you see here, I just pressed the number 3 and it's told me it's 3.00 times 10 to the power of 0. If I put in 569, put in quite a big number, just mix up the things, press equals, and it's returned me an answer to 3 significant figures automatically in scientific notation. To go back to normal mode, I can just press Shift, Setup, and then just 8, and then a 1, and that's put us back into the standard mode for the calculator. So finally, if you need any help, go to the module website, got mass resources there on using your scientific calculator. You can look at your scientific calculator instruction manual, or you can ask me in the tutor group forum. Anyway, that's all for now. Thank you for listening.